Unit 9, 1.1, state the independence of the vertical and horizontal components of velocity for a projectile in a uniform field. Now this is a gravitational field, so basically it means that your g value, which we usually take as 9.81 meters per second to the negative 1, is constant right the way through. So we have a diagram here, and this is of projectile motion. So you have a object that is shot off at a certain angle to the horizontal, and we're going to call it in this diagram V0, and it's to an angle theta. And this will be into two separate components. So if I just draw it a bit bigger here, if we have our to the horizontal like this, and this is theta, then we have our vertical component, so our V vertical, or I'm going to call this Vy, and our V in the horizontal, which I'll call Vx. And I think all of us will be able to realize that Vy will equal the velocity of, if I call that V0, it's going to be V0 sine of theta will equal Vy, and Vx will be V0 cos of theta. Now the important thing to realize is that in these two components, your V in the vertical, this will be affected by 9.81. So there will be a force on it, and your formulas, these formulas over here will apply. This is from the data booklet. Plus the V is equal to U plus AT. So in your vertical component, you'll be using these formulas. But in your horizontal component, there is no force that's going to be acting on it, provided we have no air resistance taking place. So your Vx, this is going to be a constant value, and your Vy will be the value that you will work into your equations here. And we'll do one or two examples of using this in a moment, but let me just finish looking through the curriculum for this. So we describe the trajectory, that is the path that it moves through, of the projectile motion as parabolic in the absence of air friction. So this shape over here is in the shape of a parabola, and basically the reason for that is this is your displacement, this is your S, and this is your T, and we can see here that we have got in the form of a quadratic equation with t squared, but remember here our velocity here is in the vertical. That's the one that we're going to use for the u there. Describe the qualitatively the effect of air resistance on the trajectory of a projectile. Now what happens with air resistance, obviously it works in such a way that as you're going upwards, air resistance is going to work in the opposite direction. So you're going to get force resistance in that direction, and also in this direction over here you're going to get a force of resistance in that direction also. So it's actually going to cause there to be some deacceleration in your horizontal component, and also for the first part it's going to, in the upward part of the trajectory from there to there, it's going to lead to a greater than normal deacceleration. So your deacceleration will not be g is equal to 9.81, but it will be greater than, it will be a greater value. So you're going to find that your object is going to deaccelerate greater, and therefore won't reach the same height. On the way down, your acceleration, so this may be say 11 meters per second to the minus 2. On the way down, when it's going in this part of the trajectory, we're going to find that the force of resistance in the vertical is going to be in that direction. So this g value will actually decrease. So this is going up, and then going down, it will decrease. So maybe it will be something like 9 meters per second to the negative 2. So you're going to get something like this. Something like that. It's not going to get as high, and it's not going to go as long, because also there's obviously this force of resistance in the horizontal direction. And we need to be able to solve some problems, and I'll do that in the next video.